All right, so anyone can see it, or everyone? Cool. All right, so during the Builders program, I was working on 2 new features for SnarkyJS, and this is dynamic arrays and JSON parsing. During this presentation, I'll go a bit more detail into the features, what you can do with both libraries, and then later in the Q&A session, if you want to, we can have a bit deeper look at the code if you're particularly interested in something. Starting off with dynamic arrays, you can essentially use them for any type. So whether it's fields or booleans or any custom struct that you create yourself. And I want to introduce you to kind of the methods that you can use on these dynamic arrays. The first thing you'll do is basically you'll declare your custom array, similarly how you would declare a custom struct by providing the type, so in this case, for example, field, and the maximum length of that array. The longer your array can be, the more resource intensive the proof computation will be. But the good thing is also you can use it inside of smart contracts and pass it in as an argument to your function. And here you can see an example how such a dynamic array would be initialized. So here I just have a simple array of 1, 2, 3, which is of type field. And then all I have to do is I take my field array .from and pass in the values, and that's how I got my array. So the first features you get is obviously getters and setters. So if we take our array 1, 2, 3, and we just get the first index, right? It just returns 2. We can also set the value then at a specific index. So we can set the first index to 5, and then our array would become 1, 5, and 3. Additionally, you can push fields into the array. So if we push 4, we get 1, 5, 3, 4. And then we can also pop, so remove elements from the end of the array. And we can specify how many elements we want to remove. So in this case, for example, we're removing two values from the end. So 1, 5, 3, 4 becomes 1 and 5. Our next 2 features are concatenating and inserting. So let's say we have one array, which is 7 and 9, and we have our previous array of 1 and 5. Then we can just create, call array.concat, and then we pass our other array. And this will create a copy. So this will create a new array, which will have 1, 5, 7, and 9. Basically, all the values back to back. Here, it's important to note that these arrays need to be of the same type. So I couldn't concatenate a field array with a Boolean array, for example. And then we can also insert values at any index we want. So we would go array.insert, and then at the first index, we want to enter a 3, and we end up with 1, 3, 5, 7, and 9. At this point, you might notice that when implementing these features, I was very closely following the essentially JavaScript implementation of arrays. And I tried to offer pretty much any feature that JavaScript also has just inside of SnarkyJS. All right, the next one that we have is slice. And this will allow you to provide a start index and an end index. And it will give you basically a portion of that array as a new array. So if we slice our array from 1 to 4, we can see that the middle 3 values are returned to us. Then because I think it's a bit hard to iterate over dynamic arrays, because for loops work with traditional numbers and not fields. I created basically a copy of the JavaScript map function that allows you to create a new array and populate it basically with the results of a certain function that you put. So you call array.map, and x is the value, and I is the index. And then here you can do essentially any computation you want, and you return the new value, and this will be replacing the old value at that array. So in this example, for example, I'm multiplying the value with the index, but you can put any arbitrary code in there that you want. Lastly, I think another very useful feature would be asserting that a certain value exists inside of an array. So what you can do here is you can do array.assert exists, and if that value that you need inside of the array does not exist, it throws. And here again, this really depends on your type. So if you have your custom structs, you can also assert that your custom struct exists inside of that array. Lastly, I think this should be the last feature. You can also just simply copy an array. So if you call array.copy, this will basically return a new array to you. And then any changes you do to that, for example, pushing a new array, will be in the new array. So if we have the array 1, 2, 3, 4, 1, 2, 3, it will still persist after you've used copy. Most of the methods modify the original array, except for copy, slice, concat, and map. All of these, they return a separate array for you. All right, and now we can move on to JSON parsing. What I really like about the dynamic array library I built is that it's very extensible and can be used for a lot of different features. So for example, the JSON parsing library was built on top of my dynamic array library. SnarkyJS already includes a class character that allows you to represent a single string character. And my JSON object, or my JSON parsing, is under the hood is essentially just a dynamic array of characters. So here you can see I have defined a JSON object. This could be a result from a data, like API call, where I get a list of users, and they all have like different properties. Like they have a name, they have a Boolean value, and they also might have an age. And to create that JSON parser object is very easy. All you do is you call the parse.json function and pass in your string. It will take care of parsing the string. Also, it will minify it, and then it's ready to be used. The first feature is parsing a key. So you can see here we have result, and then it returns the array to us. So after calling JSON.key result, this is how our new JSON object would look like. So we can see that essentially the brackets and the result has been removed, and obviously everything, if there were multiple keys, all of them would not be included here as well. So all that's left is our array with our two users. And now the next feature would be getting an index from a specific array. And here, for example, I'm passing the first index, and this returns me my name, whether I'm an active user, and my age. So if we compare it to here, basically every other index is removed from that array of characters. And lastly, and that's, I think, what's the most important thing about this, is we can validate these values. And for this, I basically provide 3 functions. The first is we can assert that a certain key, or again, index, you can use here whatever you want, is equal to a certain string. So here I assert that name is equal to Daniel. The next function we have is toBoolean. So I can try converting any value under is active to a Boolean. And this gives me back really the Boolean value true or false. And then I can even choose to do other things based on that. So I don't even have to necessarily call assert true. I can just make sure that this is what I'm expecting in that case. And same goes for numbers. I can convert basically because this is all of these are strings, right? The string 27 is then converted to the number, or in that case, it's true. And then I can do whatever I want with that number. If it was, for example, let's say it's an API call from Alpha, and I want to do some further calculations with it, I could just use that number. Or in this case, where I assume it's an age, I can assert that it's greater than 21. It's important to note that if I would try calling toBoolean on age, this would fail because there is no Boolean in that field. And the same goes for index and also for key. If I would try to get a key from this wouldn't work. So basically, for this to work, you need to know the JSON structure in advance to be able to parse it on-chain to validate some values or to extract some values that you can use further on. And that's pretty much it. I would maybe want to mention what my challenges were with the overall project, and also what I envision doing next. For me, it was very interesting working with ZK apps because it's very different from traditional programming. So yeah, like I'm saying here, everything is a mathematical formula. You don't have if-else branches, but you can essentially achieve the same result by doing math. And also, this has implications on the performance of your program. Usually, if you have an if-else branch, you would have, if you go like the else, if the if path is very computationally expensive, but you go the else path, then none of this computation happens. While with ZK apps, because both values are computed and then math is performed on these values, you basically need to really look how you can optimize your circuits so they're computationally less intensive. And also, some operations are just more computationally intensive, and that's a bit unintuitive. So as an explicit example, using greater than or less than is a very easy operation for a processor to do because it's just built straight into the processor. But with ZK apps, it was later revealed to me, essentially, that this is a very computationally expensive operation, and there are workarounds how to solve this. So it was a great learning experience as well. What I'll do next is, I think my ZK app journey is not over yet, and I'll learn a lot more. And as I learn more, I'll be able to further optimize my circuits. And I would also want to kind of increase the test coverage a bit, so it's I can sort out some test cases or edge cases to make sure everything works as intended. If you want to check out the repository, here you can see the link. And I really enjoyed working on this. It was a lot of fun. Yeah, thank you for your attention.